This is Physics Prism, once again with a very exciting series to all of you who are preparing for JEE Advanced and Olympiads. And this is going to be very exciting where we solve IRODOV questions over 100 weeks. Yeah, this would be a series. On every week we will be launching a video on detailed solution of IRODOV, and before that we will be launching the question that if you answer correctly in the comments, you will get a shout out in our next detailed solution video. So let's get started. Here we have IRODOV question 1.138. A horizontal plane supports a stationary vertical cylinder of radius r and a disc attached to the cylinder by a horizontal thread of length L. Initial velocity of v is imparted to the disc, which is perpendicular to the thread. Find the time it will take for the disc to move along the plane until it strikes against the cylinder, assuming friction is absent. So, how do you solve this problem? How to attempt it? See, this is a very interesting problem where not much not much mathematics is required. So here we have a diagram which is given obviously in the book, the IRODOV, and the book says this is the diagram from the top view. So this is going to be the cylinder, this round figure, and this is our disc over there, which is imparted with a v velocity and tied by a rope of length L. And this is the trajectory. The yellow line is the trajectory of this disc when it moves along the constraint of that rope. So to solve this, we take a arbitrary position of the disc, say somewhere about here, and we analyze how to solve it. So if we take that portion, then there must be a tangential line connecting it, right? A tangential line connecting it, and we call it, give it white color, and this is some part of the rope. So what part of the rope is this? See, some part of the rope is already wind up against the cylinder, right? So this part is this part over there. This is making an angle theta, and so if this makes an angle theta, assume that it makes an angle theta, and this is radius r, then this arc length will be r theta, and so this rope length will be L minus r theta, right? This is very obvious and basic. Now let's talk about some really interesting facts. What is that? Suppose we take a very small element of this distance, because to find the time, as we know this formula that t is nothing but distance divided by velocity, right? Because velocity is distance divided by time. So if we could find out the distance of the trajectory, and if we could find out the distance of the trajectory, we know the velocity. Since the rope will not change the magnitude of the velocity, it will just change the direction of the velocity. So it's pretty much it. Now how to find out this s? So to find out this s, we need to take a very infinitesimally small segment of this trajectory. Now if we could find out that very segment ds, then we can integrate over that to find out s, right? So what is that ds? Can we find out in terms of theta, L and v? Yes, obviously we can. Why not? Let's find out. So let's take a very infinitesimally small displacement ds over here, okay, and we connect it to there. This is the rope, and this is our d theta change in the angle. So this whole thing, this whole angle is then, what is it? This whole angle is then theta plus d theta. So the arc length will be r times theta plus d theta. Now if the arc length is itself r times theta plus d theta, then this one will be L minus r theta plus r d theta, right? Is it? Isn't it? Yes, it is. But wait, theta is being added to a very small amount. I mean theta is being added to a very large amount. So we can ignore this theta with respect to d theta with respect to theta. So we can pretty much say that this r d theta term will get lost. And think about it, it must be, because d theta is a very small change. So this length is obviously the same. This length remains the same. And so the angle between this remains d theta. And if this angle is d theta, and we know that the length of this arc is L r theta, so we can easily say from arc theorem that ds is nothing but that's L r theta times d theta. So we get ds. What else do we need? Now we need to integrate over there. Well. How do you find the bounds of the integration? Okay, so that's a very pretty interesting problem to finding the bound of the integration. See, at t equals to 0, that is s equals to 0, we know that theta was also 0. When was that? Well, when the object was over here, the disk was over here, theta that it made with respect to this line was 0. Yes, I agree. What more? And when the L will completely wrap around this disk, that time this arc length that it covers around it, the arc length that it covers around it, that I am marking in blue, will be exactly L times R, right? And not L times R, sorry, that arc length will be exactly some angle over here, say it phi, and that arc length is L, not R, and that must be equals to R phi. Obvious, that's pretty much obvious, that length must be L, that arc length, and that must be R phi. So if that is R phi, then we get our initial theta must start at 0 and end at R phi. No, not that, L by R. Yeah, L by R, because phi is L by R. Well, in our next page, what we got is ds is L minus R theta times d theta, right? So this is nothing but L d theta minus R theta d theta, and integration over all this is S. What are the limits? We have just discussed about that. We have just found out what the limits are. So the limits are from 0 to L over R, L d theta minus R theta d theta. This L theta will yield up our L squared over R term, and this R theta d theta is nothing but R times L squared over R squared over 2, because this term is theta squared over 2, so we put the limit and we get L squared over R squared, that term. So, what can we do next? See, we have here 2r squared. So, if we take the LCM, we get 2r squared. Since 2 is to be multiplied and 2r is to be multiplied, 2r l squared minus r l squared. Let me write it properly. 2r l squared minus r l squared over 2r squared. What is it? This is just simple algebra. We get r l squared over 2r squared. One r cancels another, and so you can write it l squared over 2r. So that's it. That's our s. That's our s. Then are we done? Yes, we are. We know that our t was equals to s over v, and we know v, we know s, put it over there. So we get l squared over 2rv. That's it. That's it, guys. So if you really like it, hit the subscribe button right now. Hit the like button and stay with us for till the end of this whole playlist, where we discuss all about IRODOV questions. And upcoming video, I'm going to post a question. Anyone who would give the correct answer in the comments would get a shout out in our channel. And in the next video, we are going to post another detailed solution of another integrating problem of IRODOV. So stay tuned. Signing off, Physics Prism.